Okay, let's move on to set. Before we continue, I think it's good to understand the differences between the three. Of course, list is the most generally used and the most flexible among the three, but there are some efficiency considerations when it comes to when to use list, set, or tuple. Set allows faster operation because set is unordered collection of unique items. So the good thing about set is whenever you try to add an item to the set and the item already exists there, it won't be added. So it keeps the set clean and unique. So it automatically removes redundancies or removes duplicates. With tuple, as we can see, tuple is important to keep data integrity because it does not allow modification once the tuple is created. Right? So let's see the use case of sets. Here, as we can see, set is declared with curly brace as opposed to square bracket in list and parentheses in tuple. The operation is about the same, but the difference between set and the others like list and tuple is that you cannot subscript it because as we remember here from the definition, set is an unordered collection of unique items. So what you can do is you cannot do it this way because there's no clear definition of who sits at index 2, right? So we have to remember that we are not using set that way where we find the element at particular index. But what we want to do with unordered set of collection is we want to find whether an element exists in the set. So we can do it by doing this one. For in unique numbers, it will return a boolean. So it is very important in condition. For example, if 4 in unique numbers, then print 4 is in there, right? So we can do it this way. Also, the in notation in Python is very important too, where we can use this for other things as well. So let's say if hello in hello world, it will return 2 as well. We can do it for a list as well. If 7 in 7187 print yes. Yep. So the in notation is very flexible as we can see. Right. Let's move on. So we have declared our set like this, and we can also add elements, but again remember the orange is not going to be added at the back of the set, but it's just to be thrown in the set, right? So now the unique fruits look like this, but again there's no guarantee that the orange will stay in there. It's just for printing purposes that we see it, oh the orange is at the back, but actually it's not, right? And then if we try to add it multiple times, it does not work. So it will stay as one orange, right? So this is very important for consistency purposes because if we have this as a list, what we have to do is actually we have to check first whether the element already exists or not, right? Because if you keep on appending to a list, let's say we append orange 2 times, what will happen to the unique fruits is that you get multiple oranges there. So with list, what you can do is actually you check first whether orange is in the unique fruits or rather not in, right? Then only you add the orange. This way you only have one orange. So this is how you replicate set with list. Right. Moving on to removing elements, it also works like list where there's a function remove to remove the banana. But if you do it with no banana there, as we can see, it will say the banana is not in there anymore. So in here, we can do a checking, for example, to prevent the app to show an error, we can do it this way. If banana in unique fruits, then only we do the remove, okay? Then the app now doesn't show an error. Let's move on to set operations. Now I have prepared these. What's unique about set that it allows these operations that is very common in mathematics. So we have union, intersection, and difference. So we have two sets here, 1, 2, 3, 4, 5. The union between set 1 and set 2 is 1, 2, 3, 4, 5. Okay, even though there's multiple trees there, we do not allow multiple trees to be shown in there because the result of this operation is still a set, meaning there will be no duplicates, right? And then intersection is 3. Of course, as we can see, 3 appears here and 3 appears there as well. And the difference between set 1 and set 2 is 1, 2. So here we want to find the numbers that exist in set 1 but not in set 2. We do it this way. And the other way around, you have to flip the color and the parameter. Here what you will see is the 4, 5. So in case you already have a list and you want to do such operation, you can also do it like this, 1, 2, 3, and then B is 3, 4, 5. You can convert it to set first by doing this set parenthesis A and then union set B. Okay, you'll get the same thing. When you convert the A to set, what you will get is a non-duplicate set of numbers that is unordered from the array, right? Let's say we have multiple trees there. The result will still be the same, right? So let's say we print A and then we print set A. As we can see, when we print it as set A, you'll see that the trees are removed, right? So you get a unique list of items. So that's how set works. Catch you in the next one.